Okay, hello everybody, and welcome to Tea with Chloe in the morning. Ooh, got my Christmas nails too. Bianca and I went out. I think it's loud. Yeah, Bianca and I went out this weekend. We were in Windsor for her work Christmas party. We were in Sarnia as well, visiting friends, and we went and got our nails did. They're not like perfect, but they did match my dress. We matched, Bianca and I. Anyways, today I'm Chloe, co-founder of the Marma J Foundation, and I guess lead of the Marma J Research DAO. And through the Research DAO, I try to tangibly provide support towards the crypto ecosystem, I guess, by working on the Unclaok crypto engineering study group in Rust. So that's what the CESG stands for, Crypto Engineering Study Group. There's a syllabus here going through the Rust Crypto Engineering Study Group and all of its glorious details. Why you might want to join the study group, why you might not want to join just yet, but we're probably going to have a study group in the spring or summer going through more of this information. And then the syllabus, which is being added to week after week. We're currently at week 4, and that is why I'm going through this topic currently. So, chapter 7 in the textbook was assigned for week 4 originally. So we have adjacent readings to support. The idea is that the book predates the general rise of authenticated encryption schemes, including GCM and Cha-Cha 20-Poly 1305, which I kind of streamed about last week and kind of went through the chapter session 4 notes in week 4 reading materials as well. And I kind of have the notes for week 4 here. So I kind of we were talking about, and I'll go to the actual notes as well so we could see them. But there you go. Went through GCM, Galois counter mode, a little bit as well. Designed for a block cipher of 128 bits. It can take full advantage of parallel processing, so it can make an efficient use of like hardware implementations to speed things up. Probably some software implementations as well. Cha-Cha 20-Poly is an AEAD algorithm that combines Cha-Cha 20, the stream cipher, with the Poly 1305 Mac. It has fast software performance, and without hardware acceleration, it's still usually faster than GCM with AES, for example. Then I kind of read through very quickly. I think I stopped the stream before I even got through the entire blog here. It takes 2 to Cha-Cha Poly or whatever. I can't even remember the name of the article. Here it is. It takes 2 to Cha-Cha Poly. Very informative article for me, just in general, like putting things together, discussing why they want to change it, the security of the change and implementation. Wow. I also didn't check to see if my stream was working, so I will check that in a second. It says even live for 4 minutes and 0 dropped frames. Always great to see that. As well, sorry. Jeez. I should put a, in my screen right below here, there's nothing there, but I should put another image of the Marma J Research DAO. And I feel like I should do it right now before I really get into this stream, potentially. So we'll see. Let's go to, I'll try and do this while I'm checking to make sure I'm live, but my YouTube did actually ping me that I'm live. I do hear the audio. Keep this here. Actually, I'll try and also turn off the vibrate of my phone because that'll definitely cause some issues. Okay, so this is, got Marma J Con, Foundation, DAO, sub-DAOs, that's where I want to go. Eventually, we need to have Marvin J research with its own page, but for now, I just need this. Save image as research that. Excuse me. Okay. Now, I don't know if I have to restream. I don't think so. I think I can just add an image source. Create image 2. Upload file. Downloads. There it is. Oop, there it is. Does it fit? Yeah. Probably a bit bigger than that one. There you go. Perfect. I don't know if that looks good or not, but I didn't like how it was just, oh no, wait. That's not the right size. Oh gosh. Maybe I can just, oh gosh. I'm going to have to resize that. Or get someone to resize that. Okay, one more thing and then we'll see. Maybe I can edit it. Cancel. Cancel. I should not spend more than like 2 more seconds on this. I was just gonna bring it down, but it really wants to go there. How's that? It's not perfect, but it's good enough. No! It really wants me to like change it. There we go. That way. Oh my gosh. It is difficult. Should I just do that and cut off my notes a tiny bit? No one needs to read my notes at the bottom, right? Sure. I need to move on. Let me check my messages. Okay. Let me get back to this. I also closed the stream. So we're going to stop that. And we're going to get back to this. So after going through GCM and Cha-Cha 20, Poly 1305, AEAD, and talking about, the course in general and how we were supposed to read through the information, but we didn't, and so, now we're at chapter 4. Then there was the actual recommended reading libraries. I didn't really go through TLS. So for TLS, there was like the whole SSL TLS thing. I renamed it. Oh, it renamed it all for me. That's wonderful. So SSL, as we're going to take notes about here, stands for the Secure Sockets Layer, and it refers to a protocol for encrypting, securing, and authenticating communications that take place on the internet. What we're using right now. It's pretty cool. Although SSL was replaced by an updated protocol called TLS, Transport Layer Security, some time ago, SSL is still a commonly used term for this technology. So I guess for a while, some people still use the tech after TLS was out, and the term is just used for in general. And so I'm probably gonna take this entire note down once I get here, because I feel like this. I do enjoy how it takes the hyperlinks down as well when I take the note. Well, actually, I'm going to take this as like my general intro for now. I'll do like a quick SSL is this. Um, and then for TLS specifically, I'm probably going to take most of the notes. Yeah. They do have this whole like SSL versus TLS handshakes. So like SSL was the original protocol. Wait. Grr. Okay, so this is not even going to tell us about SSL. This is all going to be TLS, so perfect. Oh, they're just calling them both the same thing. Perfect. So I should turn these back around. Ha ha ha. Well, I didn't know if like it was actually going to talk at all about SSL, even though it was outdated. Generally, I write the notes out before I start reading about it. Not that I'm sure it's worth reading much about SSL too much, or as how it's like built. But they're completely different, so I think it's interesting seeing like why things change, and I forget the differences specifically. So, okay, so I'm just going to start reading. Way too long of an intro, 11 minutes, but you know it's Monday morning. We'll get there as we get there. As we do, I'm just going to take some general notes. And yeah, that's about it. It was working previously to have Google read this out, so let's see. Looks like it's working. Good to go then.
Call for encrypting, securing, and authenticating communications that take place on the Internet. Although SSL was replaced by an updated protocol called TLS, Transport Layer Security, some time ago, SSL is still a commonly used term for this technology. The main use case for SSL TLS is securing communications between a client and a server, but it can also secure email, VoIP, and other communications over unsecured networks.
Okay, just going to keep going. The one issue with this way of using the speech is that you can't speed it up. But I think also with more complex, well, this is not really a more complex, in-depth technical topic, but when you do have more complex, in-depth technical topics, I think this reads out the math better, from what I remember. Although, yeah.
How does SSL TLS work? These are the essential principles to grasp for understanding how SSL TLS works. Secure communication begins with a TLS handshake, in which the two communicating parties open a secure connection and exchange the public key during the TLS handshake. The two parties generate session keys, and the session keys encrypt and decrypt all communications after the TLS handshake. Different session keys are used to encrypt communications in each new session. TLS ensures that the party on the server side, or the website the user is interacting with, is actually who they claim to be. TLS also ensures that data has not been altered, since a message authentication code, MAC, is included with transmissions with TLS, both HTTP data that users send to a website, by clicking, filling out forms, etc., and the HTTP data that websites send to users is encrypted. Encrypted data has to be decrypted by the recipient using a key.
Dum, dum. Notes are always too small, but it's good enough. Encrypted data has to be decrypted by the recipient using a key. Yeah, that's obvious, but maybe I'll take it down anyway. I wonder if this one gives me the... Oh, it does, yes. Although, yeah, that's fine. We already know this, but maybe I'll just take it down again. Actually, here. That's cute. I like the entire note, but I don't like deleting all this. Meaning that two different keys are used on the two ends of the conversation. Yeah, it's cute. Data encrypted with the public key can only be decrypted with the private key. Sure. During the TLS handshake, the client and server use public and private keys to exchange randomly generated data. Ah, yes, the session keys. There you go. Symmetric encryption. So you have asymmetric encryption at the beginning, where you have public and private keys that help you set up communication with the client, the server, or whatever. Then you have symmetric encryption, or just explaining it. I guess I think explaining it just for fun. Let me see. Unlike asymmetric encryption, two parties and always use the same key. After the thing, both use the same. Yeah. One session keys are in use. The public key are easy one. Session keys are temporary keys. I don't know why I'm not doing. I'm not.
Unlike asymmetric encryption, in symmetric encryption, the two parties in a conversation use the same key. After the TLS handshake, both sides use the same session keys for encryption. Once session keys are in use, the public and private keys are not used anymore. Session keys are temporary keys that are not used again once the session is terminated. A new, random set of session keys will be created for the next session.
We kind of already wrote that. I feel like I don't like taking these pictures. Or like taking screenshots and adding them in. They're kind of a pain. Maybe I can practice a mermaid diagram. Probably not the best time for it, but it might be. Shouldn't be that difficult. Whoa. Okay. What am I trying to show? It's a very simple diagram. Just straight arrows from one thing to the next. I feel like I already passed it. Why is it showing me the most difficult examples? That's cute. The journey diagram. So unnecessary. But it could be like hello key. I might give up on this in a few seconds if I can't find. This is still too. I guess this is kind of, but this is still pretty complicated for what I want to show. Yeah, I'll do this another time. This is kind of what I'm looking for. This normal diagram here. But yeah, I'm sure it's very straightforward. It's probably. Yeah, I got other things to do. I could just be like, I just want to get some sort of visual, you know, without having to. Then you have your. Maybe I'll key. Then you have your. Oh no. Oh, it'll give me the link. I wonder how that will turn out. I'm going to try that for now and see if that link actually works. Yeah, sure. No harm, no foul if that works. I'll push it up to GitHub later and see if it actually shows the picture. Because, yeah, I mean, once you have the picture, it's relatively straightforward that you get like a new key. We already wrote this above, too. I don't know how many times I want to repeat the same information. Okay, we already said we use the same key. I mean, they use the same session key. Like, I feel like, oh gosh. Same key. This is real. Okay, this could be relatively important. Like, once you start using these new keys, you don't use the old keys. Picture to make it very clear. They're temporary. We've already talked about that, man. A new random set of keys. Maybe if people that might help somebody be like, oh, how are we generating these? They're random. They're not like predetermined. Sure. Authenticating the origin server. There's just lots of just random points. I'm not going to make headers for each of these. Actually, let's just do 2.
Authenticating the origin server TLS communications from the server include a message authentication code, or MAC, which is a digital signature confirming that the communication originated from the actual website. This authenticates the server, preventing on-path attacks and domain spoofing. It also ensures that the data has not been altered in transit. What is an SSL certificate? An SSL certificate is a file installed on a website's origin server. It's simply a data file containing the public key and the identity of the website owner, along with other information. Without an SSL certificate, a website's traffic can't be encrypted with TLS. Technically, any website owner can create their own SSL certificate, and such certificates are called self-signed certificates. However, browsers do not consider self-signed certificates to be as trustworthy as SSL certificates issued by a certificate authority.
Okay. TSL communication for the message. Okay, we don't need to write it out twice. We don't need to. Sure. I feel like that literally tells you the entire thing, but yeah, it's a Mac. What is an SSL certificate? Ugh, I feel like it literally, I'm just gonna do that. Take the header, take one little, oh, they made that even bigger than authenticating the origin server. Crazy. Anyways, file. I'll take that down as a typical top level note. The data file with the public key and the identity. It's like a Yellow Pages book. Okay, yeah, so without this, let's just put that in the top. So it's, I lied. Technically, any website owner can create their own. Like, you can go to your local, like, you can create your own phone book and write your own name and phone number in there. And it's called like a self-signed certificate. However, browsers do not consider that as trustworthy. So if you write your own number in the phone book, it's not as trustworthy as your phone number being written in by a cell phone provider, or like Bell or Rogers if you're in Canada, or Verizon or something. That's relatively like just good to note down, I guess. You can do it yourself, and this won't be trustworthy. So how do you create a decentralized, trustworthy certificate authority that can sign certificates websites. How does a website get a... Okay, well, I'll just do this again.
How does a website get an SSL certificate? Website owners need to obtain an SSL certificate from a certificate authority, and then install it on their web server. Often a web host can handle this process. A certificate authority is an outside party who can confirm that the website owner is who they say they are. They keep a copy of the certificates they issue. Is it possible to get a free SSL certificate? Many certificate authorities charge for SSL certificates. To help make the internet more secure, Cloudflare offers free SSL certificates. Cloudflare was the first internet security and performance company to do so. Cloudflare also has worked to optimize SSL TLS performance so that websites moving from HTTP to HTTPS do not have their performance impacted. For more information about SSL options with Cloudflare, see our developer documentation.
Cute. I mean, I'll do this just for like later if I ever come back to this and I'm like, oh, I want to learn more about this. Developer docs, I feel like is always the best place to go. The S stands for secure. Okay, fine. That's this could be a whole like article on Unclaok right here. Just like, what's the difference between HTTP and HTTPS? Okay, well this is gonna get taken down because it just looks so fun. I don't know why I did that, but okay, simple enough. And I kind of write these with the idea that if you just kind of came to here, clicked these two links, read the intro, and just read this little purple part at the top, hopefully you'd have like an understanding of the article and be like, I get it. That's fine. Like 30-second, 1 minute skim. Everything else is just like a website. Okay, that's supposed to be the case, right? Yeah. Maybe I'll put that. If people are wondering, like, why you see this, like, maybe that'll help someone, like, I don't know why they put it after the period, like, that, isn't that gonna stress me out? Like, isn't it, yeah, let's fix that. Isn't it supposed to be, like, unsafe then a period? I don't know, I think so. Pretty sure. Okay, that's the first one. Relatively straightforward. I'm just gonna close the article. What was this one again? Oh, extra paper I wanted to read about AEAD. I think it's from last week though. I don't think I'll have time. So this one is just talking about what happens in a handshake more specifically. So the TLS handshake. I feel like I should link to a heading. I feel like this is such a big. Okay, so TLS handshake. And then I should just continue instead of doing that weirdness. I should just take this as a high level note, and then I should just come down. Maybe I'll add to it too. But. Okay, so going to the second article, I'm gonna just check my notes quickly. Oh, cute. Okay, sorry, having a lot of fun on Twitter. We just released our hackathon page for, I guess, the Marmaduke Research DAO, in collaboration with my wife, Bianca. But we kind of have it's very rough, but trying to at least kind of get together a hackathon. Actually, I'll show it. Why not? We're here. I'm kind of just. I like breaking up the streams anyway. So if I stream one topic for that was only 20 minutes. Actually, that was pretty quick, but still breaking it up a little bit. So this is the Marmaduke hackathon page. This needs to be expanded a bit or sized differently because of the sizing issues here. Just needs to be a bit bigger. It's no big deal. You can just kind of click get started. It brings you down here for now. Nothing too crazy. So at the Marmaduke Foundation, a hackathon, hackathon, is an event where people come together to collaborate, design, build, and present an innovative solution to a problem, and then pitch a final concept, prototype, or product to a panel of judges. Okay. At MarmaJCon, everyone is a hacker. This hackathon welcomes computer programmers, graphic designers, project managers, interface designers, and more. Join us to hack for social good. What will you build? Okay, so just very high level, very general. And yes, this is for the MarmaJCon hackathon, but the idea is this hackathon should run generally all year round. And maybe the bounties will be most accessible around MarmaJCon in January each year. Okay, so we start with MarmaJEDU, which is a whole bunch of resources. We try and start top to bottom all the way through, left to right in terms of difficulty. So we have some very straightforward MarmaJ guides to go through. We have a simple way to get a near account, this is incorrect. Yeah. This is not the right link. Whoops. What did I just do? Here. Take a little screenshot. Get a near account goes to the repo instead of the doggy thing. So, perfect. It's the last one. So, a screenshot will pop in. Oh, there it is. It's already there. My bad. This links to GitHub repo instead of shard dot. Okay. Ethereum and tweets. Wonderful tweet threads about just Ethereum, the world computer, all of that kind of stuff. And I know my screen's actually kind of small. I don't know why it's that small. It shouldn't be that small. Okay. Then getting into how to use Vim. So I don't like being presumptuous and thinking that everyone uses VS Code. I think just knowing how to use Vim in general is a good skill to have. Harvard CS50 computer science course, because it goes through C sharp, C++, oh gosh, go through C, might go through C, goes through Python, goes through SQL and a bunch of other things. It's pretty quick. You can watch it on YouTube and breeze through it. Free Code Camp, data structures and algorithms. I love the Free Code Camp material. This specifically is quite great. What are all these messages down there? Oh, that's a YouTube video. Interesting. Why is YouTube on? Okay, let's delete that. It's bothering me. Solidity programming course, Crypto Zombies. If no one's gone through Crypto Zombies before, I think it's a wonderful way to learn the basics of Solidity. Then Tmux goes with Vim. It's a way to kind of have your terminal, but encompass your entire screen and make multiple windows for your terminal. So I think it's you can go through this whole side in 2 weeks. So, for example, when we run like boot camps and like summer camps for kids in Antigua, the idea is we'll run through like maybe a month of like hacking in the summer, and it would be like 2 weeks to go through this left side, and then 2 weeks for this right side. And this right side's a lot more advanced, so it gets straight into hacking smart contracts with Ethernauts, the Rust language book, pretty much. Oh wait, the Rust Lang book on YouTube to kind of watch through it. Rust Lang book on the actual book, getting into cryptography basics, getting into number theory, an article, Unclaok in general, so cryptography engineering in general. ZK Whiteboard playlist, a YouTube playlist going through a bunch of amazing zero knowledge stuff. So in cryptography, then cryptography for developers, an actual like hands-on way to start getting started in programming some of this stuff. And then a graduate course in applied cryptography is such an amazing textbook in my opinion, but it is very research heavy and in math heavy. Then we have our bounties, again, just very basic bounties. Try to keep it simple. Which DAO is running the bounties right now? Just the research DAO and the gaming DAO, keeping things, again, very simple for now. You might add to this, but for now it's just the two. Then we have the research challenge and the gaming challenge. Okay, so you can earn near or you can earn PXT for these different challenges. More information will be added soon. And then we have like, I'm a beginner, how do I get started? I'm advanced, how do I get started? And so trying to keep filling out this information week after week. We'll have hopefully some bounties for people submitting examples and stuff like that. So that's just a quick overview of the Marmaduke Hackathon page as we have it currently. I should probably like full screen it so you can see it in all its glory. So we'll do a nice little, Marmaduke Hackathon page. So yeah, you can kind of come down here and go, okay, I'm a beginner, let me just get started. And it'll kind of bring you down. This near developers page is actually probably all you need to do most things. You can create a near app, you can quick start, you can get contract examples, you can go to Aurora from here, or Rust SDK. You can kind of get wherever you need to go. There's like, they have daily calls for developers, and like, you can kind of just, do things on Solidity coming from Terra or Solana. You can get Rust stuff on Near. You can do Substrate with Octopus. You can do Rough Finance, Sweatcoin. Like, you can kind of see, there's AstroDAO and Satori. Q. I haven't actually seen all of this stuff before. You have grant stuff, join Discord. Cute, DAO Records. Adorable. And you can like learn to code here. So like maybe we'll save this link. I didn't know they still had the certification stuff. Let's click it. Yeah, ew, what is that? There we go. Let's use this link. It's a good link. Maybe yeah, sure. GM. I'll call it a beginner resource mainly because let's make sure the stream is still working. It looks like it is. Mainly because we have to fill it out. One more, but like having again near developers and then like learn, like I don't know, but learn to build on near developers. It could go in Marmaduke EDU obviously, but I think honestly that what's here is just generic and basic and already enough. We could add a bit more, but like on mobile, for example, it's already so much. We're trying to keep everything very high level on the Marmaduke EDU side. On the like, we really want people going to the beginner section and like getting their hands dirty. And this sadly doesn't really get your hands that dirty, but it's one link that gets you through like wiki and documentation and different pathways you can learn. So like learning path for entrepreneurs, new to Web3. The workshops and guided comment are, again, all very basic, like Near Learning Club, Near Academy, Developer 101, 102. It's like near and far from coding. It's like introduction, a lot of it. And then the educational video series, again, very introductionary, wow. Introductionary. I can't say that word today, so it's fine. Deep dive, they have like, this is a bit more in-depth now, like NCD, near examples, products on near. But honestly, I think most people will come here, they'll see, oh look, a near wiki. Let's click that. I cannot. Oh, these tracking links are wild. Love them. But yeah, you can get like whatever you need from here. So I'll still call it a beginner resource and just learn to build on near, or learn about near, maybe, right? Like learn about near here and the near developers here. I'm gonna like learn about near and develop on near. Anyways, I need to go back to that. Was like a little. So Ernest, if you cut this up, or when you cut this up, that was like an article review about. Where are we? I need to make this smaller again too. Right? We're back. So that was an article review over how does SSL work, and now we're gonna go through what happens in a TSL, TLS. Oh my gosh, handshake. So it seems like it's actually going to give me, I'm probably going to keep the title, and I'll go with 3 again. It's going to like make it all huge, watch. Yeah. And then I'm just going to, or maybe I should just keep the same. I kind of want to like make sure I know I'm in different articles for later. But I probably don't need to. This is actually more basic. So maybe I can do this. Do this. Then start from here. What is a TLS handshake? And I feel like I probably have this right here. TLS is an encryption authentication protocol designed to secure communications. Yeah, this is more general. During a TLS handshake, the two communicating sides exchange messages, know each other, verify each other, establish algorithms they will use, agree on session keys, and agree on session keys. TLS handshakes are a fundamental part of how. It's like a cute, like overview that I'm like, ugh. I'll keep the paragraph, but I'll take some stuff out of it. It's a bit long. TLS is an encryption. Is an nothing protocol designed to secure internet communications. A TLS handshake is a process that kicks off communication that uses TLS. During a TLS handshake, two communicating sides exchange. That's cute though. I like how cute and precise the languages they're using. TLS handshakes are okay. Yeah, it's such an overview. Again, you could read this and hopefully wouldn't need to even go to this. I think I already took. Yeah, I took the SSL part. I didn't take the whole versus part, which I think is actually still relatively important. But I think it actually fits in right here, just as a high level thing. I already took the note here. Maybe I can. It's not gonna work. Oh, sorry. Oops. Where did it go? What did I do? Nope, not that. Lord, what did you do? You're right here. So I should be able to... There we go. And then I can just link to the top. I don't need to take the note again. Then we have the handshake, which is kind of annoying. It's kind of boring, but when does the handshake occur? It should be the same size, so it should be 3. We'll drop it down. Symmetric encryption with session keys. I don't want to... Yeah, I'll just put it all in right here. Gotta make some space. A TLS handshake takes place when a user navigates to a website over HTTPS and the browser first begins to query the website's origin server. A TLS handshake also happens whenever any other communications use HTTPS, including API calls and DNS over HTTPS queries. TLS handshakes occur after a TCP connection has been opened via TCP handshake. Honestly, this doesn't seem to be worth taking note on. What happens is the same as the handshake, so maybe I'll just... This is a lot more specific. Actually, I'll take a note for itself because it is a lot more specific.
During the course of a TLS handshake, the client and server together will do the following. Specify which version of TLS, TLS 1.0, 1.2, 1.3, etc. they will use. Decide on which cipher suites. See below. They will use authenticate the identity of the server via the server's public key and the SSL certificate authority's digital signature. Generate session keys in order to use symmetric encryption after the handshake is complete.
This is going to also just be a top note. Because we kind of already took that note. I just want to make sure I don't like miss out on like this. I think like noting this in like numbered form is pretty useful. Anyway. Like this, breaking it down again in a lot more detail, always fun. So what are the steps? Let's just take it down.
TLS handshakes are a series of datagrams, or messages, exchanged by a client and a server. A TLS handshake involves multiple steps, as the client and server exchange the information necessary for completing the handshake and making further conversation possible. The exact steps within a TLS handshake will vary depending upon the kind of key exchange algorithm used and the cipher suites supported by both sides. The RSA key exchange algorithm, while now considered not secure, was used in versions of TLS before 1.3. It goes roughly as follows.
I love that. I love when like articles or text. I mean, okay, I don't know if love is the right word, but I find it funny when articles or text will be like, "Oh, we're gonna try and explain it to you." So here's like a very like dumbed down version of it. Still helpful, of course. I am gonna take these notes down. This is like the funnest part of it all. Actually learning how something works in practice. I won't take down all these notes, of course, and I will have the page read it.
The client hello message. The client initiates the handshake by sending a hello message to the server. The message will include which TLS version the client supports, the cipher suites supported, and a string of random bytes known as the client random. The server hello message. In reply to the client hello message, the server sends a message containing the server's SSL certificate, the server's chosen cipher suite, and the server random, another random string of bytes that's generated by the server. Authentication. The client verifies the server's SSL certificate with the certificate authority that issued it. This confirms that the server is who it says it is, and that the client is interacting with the actual owner of the domain. The premaster secret. The client sends one more random string of bytes. The premaster secret. The premaster secret is encrypted with the public key and can only be decrypted with the private key by the server. The client gets the public key from the server's SSL certificate private key used. The server decrypts the premaster secret.
Okay. I need to take. Some of these are obvious, and some of these I'm like, okay, I need to. I need to take a note for that. Okay, so I guess they'll all get a small note, because like that, there's no way I would know that without writing that down. Let me just. Actually, these all look. Darn nabbit. Okay. Both client and server generate session keys from the client random, server random, and premaster secret. Okay. They should arrive at the same result. Okay, that's fine. Client is ready. The client sends a finished message that it is encrypted with a session key. The server sends a finished message saying it is finished message encrypted. That is encrypted. Sorry. I don't know why. A handshake is completed and communication continues using session keys. Okay, simple enough. Authentication. Let me just take it and delete the parts that are. Oh gosh. The client sends one more random string of bytes, the premaster secret. It's encrypted with the public key and can only be decrypted with the private key by the server. I mean, I'm going to keep that just because I didn't know what a premaster secret was before specifically, so I'm going to be like, what the heck is that? Authentication, though. The client verifies the server's SSL with the certificate already that issued it. This confirms the server says it is. Okay. Don't need to overbear us with all that. Client initiations. This message will include which TSL. Yeah, and this I think is the more important part. The second half of this. And then here, we reply. The server. Containing the server is this. The chosen cipher. The server random, another. I don't need to know if that's another random string of bytes. Let's just and the server random. Okay, straightforward enough. All TLS handshakes make use of asymmetric cryptography, the public and private key, but not all will use the private key in the process of generating session keys. For instance, the ephemeral Diffie-Hellman handshake. Okay, now I definitely want to take. That'll be the fun part, seeing how they differ. Not all will use the. Okay, can you? Fun. Like, not all TLS and Handshakes will use the private key. Sorry, just making sure. Do. Okay. Whoops. Okay. Not all will use the private key. Their session keys. The Diffie-Hellman handshake process is different. I am just gonna. Well. Oh no. Okay. Hello. Kind of want to take the second note first. DH. Oh, tell me what this is. I'm gonna want this. Okay. The server and client each provide a parameter for the relation when they combine the result. Ooh. Okay, you're gonna have to give me that. This sounds like the most fun part. Okay. Let's just take that down. That's the most important part of that. It already says hello. Funny, funny. I don't think you can just. Actually, you probably can. I was like, I don't think you can just shift it all over. I'm like, okay, you definitely can just shift it all over. I do want a space between them. Okay, let's read it through here too, because I haven't actually read it yet.
Client hello. The client sends a client hello message with the protocol version, the client random, and a list of cipher suites. Server hello. The server replies with its SSL certificate, its selected cipher suite, and the server random. In contrast to the RSA handshake described above, in this message the server also includes the following: Step 3. Server's digital signature. The server computes a digital signature of all the messages up to this point. Digital signature confirmed. The client verifies the server's digital signature, confirming that the server is who it says it is. Client DH parameter. The client sends its DH parameter to the server. Client and server calculate the premaster secret, instead of the client generating the premaster secret and sending it to the server, as in an RSA handshake. The client and server use the DH parameters they exchanged to calculate a matching premaster secret separately. Session keys created. Now, the client and server calculate session keys from the premaster secret. Client random, and server random, just like in an RSA handshake. Client is ready, same as an RSA handshake. Server is ready, secure symmetric encryption achieved.
It's funny, it doesn't seem that complicated to be fair, but I feel like the article is the most fun part. So I am going to go into this article. Actually, it's right here. And it seems pretty, oh gosh, I did not mean to. Let's duplicate and let's go back. Okay, not this very second, but maybe I'll add this article to the end of what I'm doing. This Cha-Cha article is relatively long too, though. And I have so many notes on that one, so I'll put this at the end, and maybe I'll take a note on it later. So, where are we? Down here. What's different about a handshake in TLS 1.3? Oh, 1 second. Sorry. One thing I did have to do. Awesome. One thing I did have to do. How did I forget already what it was? That's wild, right? It was about the hack. Oops, I just closed my YouTube. It was about the hackathon. And I was like, oh, haha, figured it out. I have to send the contracts. Sorry, I gotta check to see if the contracts are even shareable before I start sharing things. Okay, back to this before I lose track of it too much. Okay, let's just read through the next information. I'm not sure I'm gonna take a full note on this. It's kind of like, what is the difference between this version and this version, and how the client hello is different. I might take some specifics, but we'll see.
TLS 1.3 does not support RSA, nor other cipher suites and parameters that are vulnerable to attack. It also shortens the TLS handshake, making a TLS 1.3 handshake both faster and more secure. The basic steps of a TLS 1.3 handshake are: client hello. The client sends a client hello message with the protocol version, the client random, and a list of cipher suites. Because support for insecure cipher suites has been removed from TLS 1.3, the number of possible cipher suites is vastly reduced. The client hello also includes the parameters that will be used for calculating the pre-master secret. Essentially, the client is assuming that it knows the server's preferred key exchange method, which, due to the simplified list of cipher suites, it probably does. This cuts down the overall length of the handshake. One of the important differences between TLS 1.3 handshakes and TLS 1.0, 1.1, and 1.2 handshakes. Server generates master secret. At this point, the server has received the client random and the client's parameters and cipher suites. It already has the server random, since it can generate that on its own. Therefore, the server can create the master secret. Server hello and finish. The server hello includes the server's certificate, digital signature, server random, and chosen cipher suite. Because it already has the master secret, it also sends a finished message. Final steps and client finish. Client verifies signature and certificate, generates master secret, and sends finished message. Secure symmetric encryption achieved.
Okay. So it's basically saying, what was that key part that you know? There you go. You know the... Don't need all this information. Because support removed, reduce. Because the support. Ah, there we go. Okay, and then this seemed. Oh, I guess I should like still say it's for the client. Hello. And that's what's different. I'm hungry now. Might have to eat something and come back. At this point, the server receives the client random and the client's parameters and cipher suites. It already has the server random since it does it itself. Therefore, the server can create the master tree. I don't even. I guess you don't need the back and forth. It's like this is your hello, I guess. Like, yeah, server hello and finished. So server hello and finish. So when the server responds, it responds with a certificate, signature saying that nothing's changed, server random because it's already done that, and chosen cipher suite. Because it already has its own master or the master, and it has all the information from the client, and then it generated itself. It says finished. Don't need the second one there. Whoops. The most important part is this part to the left. I don't even need the comments that much. Final steps and client finished. Client verifies everything and says finished. And once it does that, you can actually secure symmetric encryption, much shorter than the RSA version. So yeah, I guess I'm happy I took down the RSA version because insecure RSA version, then saying you kind of use this Diffie-Hellman handshake version, and they kind of explain the difference, which might not be as important because they just showed me about this, and I'm like, oh, even more straightforward, makes even more sense. For session assumption. Just for retrying.
TLS 1.3 also supports an even faster version of the TLS handshake that does not require any round trips or back and forth communication between client and server at all. If the client and the server have connected to each other before, as in, if the user has visited the website before, they can each derive another shared secret from the first session, called the resumption main secret. The server also sends the client something called a session ticket during this first session. The client can use this shared secret to send encrypted data to the server on its first message of the next session, along with that session ticket, and TLS resumes between client and server.
Smart. I feel like this is just one thing you take down. Although I don't need... Why is there no space on the end of this one? I'm sorry, they don't all need a space, but... don't really... The server also sends the client something called a session ticket. I don't like that. Just a session ticket. During the first session, the client can use the shared secret, because the session ticket, the server obviously has it, the client now has it, to send encrypted data to the server on its first message of the next session, along with that session ticket. So guess what? 0 round trip. 0, yeah, round trip transmission or something. What is a cipher suite? They talked about cipher suites so much in this chapter. Okay, A set of algorithms for like AAD. There are a number of cybersecurity IDUs, and an essential part of TLS handshake is agreeing upon which one will be used. See how does it work, which we already saw. And they have a diagnostic center. Honestly, this is just like for the top of the article, I feel like. Yeah, like, I don't know. It's just like so random. So random. Cool. So this one's all done. For now, I think this is a relatively useful article. I can come back and use this to write articles for Unclaok. I'm hungry. Not tired. I mean, I'm a little bit tired, but mostly hungry. 10:30, good time. I might have to speak with some of the oh, shoot. Okay. Oh. So actually, I will stop the stream. I do have to get something done real quick. Then I'll come back and I will maybe write some. I probably will write some notes on Chachapoly specifically, just some high level stuff about the intro and what is an AAD and all that. I'll probably read through this just for fun, just like it seems interesting. I might not take notes on it per se. I'm more like falling asleep back here. And then I want to try and maybe find some other resources that maybe we can go through for week 4 for like SSL or TLS specifically, and for me like how to actually start working with TLS in Rust. So I am gonna stop this for a bit, get some breakfast. I'm gonna go through 2 more articles. I mean, this took me an hour with like a 10-minute intro. So I assume if I'm back here by it's 10:30 now, so I'm back here by 11 a.m. I should be able to finish these 2 articles by noon, and then spend the afternoon looking for new articles. Although I do have to meet with some people and stuff as well, but so far so good. I'll probably just make a part 2 to this and keep it going. But